Hi, this is Eric with Math from the Gut. Today, I want to give you a better feeling for why the Pythagorean Theorem makes sense, and perhaps change the way that you think about math forever. Although this is targeted towards students around 12 to 14 years old who have recently encountered the Pythagorean Theorem, I believe that other students will benefit from this as well since it introduces a number of new ideas. First, some things I'm not going to do. I'm not going to prove the Pythagorean Theorem. Also, I will not just show you how to use it and stop there. Doing that leaves out all of the interesting stuff. It doesn't really help you to feel what's going on in your gut. Instead, let's look under the hood by exploring how the Pythagorean Theorem jives with our common sense. Our common sense about how it should work in 6 different situations. And by the way, you'll hear that mystical chime from time to time whenever I make a significant point or finish something important. I'm certain you'll end up agreeing that this is a very different kind of video, and I hope it helps you to start seeing math in new, interesting, and useful ways. So what's the plan? In the next segment of this video, we'll introduce the Pythagorean Theorem and work out 2 famous examples that we'll use many times later on. Then, in parts 3 through 8, we'll test drive a different idea each time. I'll introduce the first one soon to give you a taste of things to come, but first, we need a few quick definitions. Let's say that we have a right triangle, meaning that its 2 legs are at right angles to each other. We have set up the triangle so that one leg goes back and forth. We'll call this length x after the x-axis that you may have run into before. Likewise, the length of the leg that goes up and down like the y-axis is y. The Pythagorean Theorem allows us to determine the length of the remaining diagonal side, which is the side opposite this right angle. This side is called the hypotenuse, so we'll label it h. Now I know that different names will be used at school and in books, but the idea is always the same, and I hope you find that these names are easy to work with. By the way, if I'm ever going too fast, you zone out, or get interrupted, please pause or even repeat parts of the video as necessary. You know, a neat trick when watching YouTube videos on touchscreen devices like iPhones and iPads is that tapping twice on the left side of the screen will rewind things by 10 seconds. Okay, so let's dig in and take a quick look at our first test drive, the one we'll do in more detail in part 3. For this test, we first consider what happens to h, the length of the hypotenuse when the length of one of the legs shrinks to 0. We start off with a triangle here that has a back and forth length x of 7 inches and an up-down length y of 3 inches. In case you're wondering, that little symbol that looks like a quotation mark after the numbers 7 and 3 here means inches. So what happens to h after y completely disappears like this? Notice that as y changes, our entire triangle, including the length of the hypotenuse, changes right along with it. The only thing that stays the same throughout this transition is our x length. Here, take a look at it again. So what happens to h after y completely disappears? You might want to pause this video and think a bit first. We see that y is completely shrinking from 3 inches down to 0 inches. In fact, we no longer have a triangle anymore at all. It is collapsed into a line. Hopefully, you also notice that the hypotenuse and the x-line are now exactly the same. Therefore, in this case, h equals our x value is 7 inches after the y length has collapsed to 0. Now I know this may look silly, but in part 3 we'll check whether the Pythagorean Theorem behaves the way that our common sense just said that it should when one of the legs vanishes. But you'll need to hang in there with me through part 2 before we'll be ready to do that. You'll soon see that each of these test drives is given a pretty impressive title. Mathematicians love to use big words, and these names are really the correct ones to use for each test. For example, the test drive that we just started talking about is titled Degenerate Cases. And here are the names of our future test drives. But please don't worry. You don't need to follow these names around on the screen and start scribbling notes here.
No one expects that you've heard these names before or that you'll remember them later. I didn't learn these words until college. Also, their bark is much bigger than their bite. I'll explain everything in English, and hopefully the ideas that these names represent, like the degenerate case shown above, aren't too hard.
I'm also betting that you'll get used to most of these words by the end, and if you use them, you'll really start sounding like a mathematician. Either way, the important thing is that you think for yourself about the expected result during each of these cases, and then convince yourself that the math jives with what you expect. In the final segment, I'd like to get a bit personal and explain why I try to test drive every equation that I see, even ones that I've already proven. I find that doing this is not only interesting, but that it also really helps in many other ways.
Now, if you find yourself needing a little motivation or want to break from all the math, you could skip ahead to this final segment at any time. So hopefully, I'll turn you into a mathematical test driver.
So here is the overall plan. Again, don't get psyched out by these big words. And I know, you may have noticed that these videos are pretty long overall. That is because I wanted you to see how much there is to think about in just one small equation. But please pace yourself and take a break for a while if things start getting heavy. And finally, I want to hear your comments so that I can keep making these videos better for you. So please, give me an idea and you'll find your name on the Math from the Gut Dream Team list if I use it. So, see you in part 2.